This is problem 7-84 from section 7.1.5. Sketch a graph of x squared plus y squared equals 100. So let's first stop here, and that's what we're going to do first, sketch a graph, and this is going to be the graph of a circle. So we know it is shifted left or right. The h and k values are 0, 0. So the center of our circle is going to be 0, 0. And I know my radius is going to be 10 because this equals r squared. So r squared is 100, so r is just 10. So I'm saying this is 10 here, this is 10, this is negative 10, this is negative 10. So I'm graphing this, it should be a circle. That looks pretty good. Okay, so here's a sketch of our circle. Question A says, is it a function? Now a function is something that has one input and it has one output. So if I ask you if x is worth, let's say this is a 5, what is the y value? There's a spot up here. There's also a spot down here. So having one x value and getting out two y values is it's not good. It's not functioning correctly. So is it a function? Not a function. That's because I have more than one output for each individual input, or more than one y value when I plug in an x. So what are its domain and range? Domain is x coordinates. So the kind of the distance that it goes from here to here. It goes from negative 10 to positive 10. Now our notation we've been trying to use is this, which means x is literally in between negative 10 and positive 10, and it includes 10. Okay, we always want these symbols. They're always going to be less than symbols. The question is it equal to or is it not equal to? So our range is y, which is vertical, which is up here and down here. So also negative 10, but it's y now. So see, a lot of us have used the correct notation, but you keep the middle term to be x when it's range, and that's not what it is. Range goes with y. So that is our domain and range, which is basically how far across and how far up and down does your graph go. Part C says, draw a central angle that measures 2 pi over 3 radians. If you remove this wedge of the circle, how much area remains? So what we need to do, first, we're having this wedge and we're going to take it out. So we need to first find the area of this whole circle. So let's talk about that first. So area of the circle, that's my little circle, is pi times the radius squared. Okay, so for our original full circle, it's going to be pi times our radius we said was 10 squared. Okay, so if I type this in, pi times 100, I'm going to get approximately 315. We can just leave it as 100 pi. That's fine. Or you can call it, 314-ish. We'll leave it as 100 pi is fine. So what we're going to do is, if we draw in our central angle now of 2 pi over 3. Now, if you're watching this Tuesday or Wednesday night, we may not have gotten to what is 2 pi over 3 radians, so don't totally freak out about that if it's right now. But what we can do is, we know, if you do know this, right here is 0, over here is 180, but in radians, this is worth pi. It's pi radians, okay? So if you haven't explored that yet in class, I'd maybe wait to do this problem until later. But if you do know that it's pi radians, I'm going to cut this into about thirds up here. So there's 3 parts. If I take 180 and cut it into thirds, it's going to be, each thing is really worth 60. So this is 60, 60, 60 here. And this is pi over 3. Right, that's 1/3 of pi. Over here at this angle is 2 pi over 3. Okay, so really the angle that we're dealing with is 120 degrees. So again, you guys are probably more familiar and more comfortable with degrees. So I know my measurement is 120 degrees. So what they're saying is, How do I want to do this? Let me clear out my circle drawing. Except I have it drawn in pen, so we'll just redraw our circle in here. So we'll just clean this up a little bit so we know what we're talking about. So I'm going to draw my circle back in, which had a radius of 10. Boom, not going to be as perfect as before, but we get the idea. So we know we were over here. This was 2 pi over 3 radians. So what they're saying is we're going to cut all this stuff out. So we don't want that. I just want to know how much is left over. Right? So if we're looking at this in terms of my whole circle, or in terms of half of the circle, I have 2/3 of it cut out. Right? If I cut this line, 2/3 of it is cut out, and I have the other full part of the circle. Right? So now if I look in terms of the whole thing, let's say I cut it into thirds in terms of the whole thing. Okay? So this is really like 1/3 of the whole circle, and this is kind of another third of the whole circle. So I really have 2/3 of the entire circle left, right, in the green. Okay, 2/3 of this, I'm going to find the area of this green part, which is about 2/3 of our circle. Okay, so I want the area of the green part, not the blue. We're getting rid of the blue. So we figured out the area of the whole thing already was 100 pi. And I just want 2/3 of this number. Right? I want 2/3 of my entire circle. I know the entire circle was 100 pi. I want 2/3 of that because that's what's left over. If I cut out the blue piece, that leaves me with 2/3 of my full circle. Okay? So I'm just going to take 100 pi times 2 over 3, which if I multiply this as if these are both fractions, I'm going to take 2 times 100 pi, which is 200 pi over 3. Or that's going to approximately equal 209.4 units squared. Okay? So either answer is acceptable for this. So this is for part C, finding the area if we take out a chunk that is worth 2 pi over 3 radians. Again, if you haven't really talked about radians yet, I wouldn't worry about it. I'd come back to it. But I still know that that's going to be 2/3 of my circle will be left over, so I want 2/3 of the total area. So that's how we get this 200 pi over 3.